Hello everyone, it's March 19th. It's pretty late in my time. I'm looking at 10 o'clock, almost 10 o'clock p.m. So, uh, it's not the best time to do LeetCode for sure. However, we have signed up for this journey and we do not give up halfway. Not even halfway, we do not give up. Let's try it. Let's take a look at what we have today and then let's get on to it. Keys and rooms. I don't think I've done this before. Take a look. 1000, 1000. There are n rooms, and you start in room 0. Each room has a distinct number. Okay, so it's distinct. And each room may have some keys to access the next room. Formally, each room I has a list of keys. Rooms I. And each key, rooms I, j, is an integer in this, where n equals rooms.length. A key, this key opens the room with numbers v. Initially, all the rooms start locked, except for room 0. You can walk back and forth between rooms freely. Return true if and only if you can enter every room, okay? So here, initially, this room is open, so you go in, you can open 1, go in and open 2, go in and open 3. 3 has no key in it. Okay, so each room has distinct numbers, so every element, right, each array is in a room, and within the room, you can have multiple keys, right? You can have keys, multiple keys. We can enter room with number 2, 0, 1, 2. We can now enter 2 because there is no key pointing to 2. Okay, so one thought is, so this is the only one that's open, right? And that's open, and everybody else is closed. So from here, we know which ones we can open. So basically 1, 3, so we just say 1 and 3 are open. Then we go to 1 and 3 and take a look which else can be open. So it says it can open itself when it's already open, 0, 3, so they're already considered, so we don't have to consider any of these. We don't have to consider any of these. And then eventually we're going to check. So this is like it sounds like a BFS, right? Like a BFS. So the first level is this, and then we go to the second level. So the first level, this one will link to 1 and 3. And then 1 and 3 coming out. If we have visited before, we don't do it. 0 visited before, 3 we have visited. 1 is ourselves, so we don't do it. And this, and then we end. Now, after we end, we have a list. I have a set of all the rooms that we have visited. Then we just to check the length, see if it's okay. So I think a BFS shall work. The details on the BFS not 100% sure, which we will figure out as we are doing it. But the general idea, I think, is pretty straightforward. It's just DFS and not BFS, and it shall work. All right, let's take a look. We have don't have to worry about any of these. That's usual. So what we do is, I should put it here, BFX, not colons. All right, so we need a queue, which we can actually use as a, what's the one array? We have a queue, and then we for it, and then we wait. How did you do with only one array? We have an array, and then we can iterate through the array, and as we iterate through, we store in a new one, and then we swap. No, that's two arrays. How do we do in one array? we do it with one array by iterating through, and then we no, that is the one array. That is the one array solution, right? Man, I forgot how to. We just talked about how to do BFS. Is it one array and then we iterate through this array? And every time we iterate through the new one, we push into a new array, and at the end we just swap to the new array. Right? Yeah, I think that is. Yeah, I think that is the solution. I mean, not 100% sure, but I think that is. Yeah, I think so. So we have a queue. We can just do this, and then currently has 0 in it. And now we have visited. It's going to be a set. Right? Now we're going to do while queue. Now we're going to say next queue is going to be this. And then we're going to iterate through every value in it. I'm going to say for the room, right? The room value for R, for room, the room in queue, for room in queue, and then with all of the thing, I mean, we can do a turn that into a set, and then we'll do a minus, right? That would be the ones that's not. You think that would be a better solution? Well, I think we just iterate through, which is fine. All right, it's for room in queue. Actually, not for room in queue. It's for keys in queue, right? And then we can say for key in keys. Actually, it's not this. Okay. For key in keys, actually, it's right. For key in keys, if key not in visited, next queue dot append key, and visited dot add to key. And if it's visited, then we don't do anything. All right. And once this is done, we do queue equals next queue, right? And then going back, and then we have a new queue. I think this is a 2 queue solution. I forgot, what is the, is it the length, right? The length. Yeah, we use the length and we iterate through so we know when it ends. But don't we still need to? What is the one array solution for the BFS? I forgot. Anyway, so we're using this, right? So until the end, when the queue is empty, right? Right for key, and then in here, and then nothing is added to it, and then we're done, right? And visited has to be a set with 0, because 0 is visited. And every time we have a key, and if it's not in the visited, we add it to the visited, and then done. We're gonna do return len visited equals LAN rooms, right? Okay, so we're gonna do the test case. The test case is convoluted. So we'll be here. This one will be true, and the next one will be this and false. Let's fix the comma. Right, comma is always an issue. We already know it. Okay, so in a special case, well, special case is room is only one. Well, it has to be 0. Will always be true. And I'm just thinking, oh, actually, it has to be a array again. Thinking out loud. So let's say it has 0 and a 1 has 1, and that one will be false. Right? Yeah. Okay, and we're gonna do rooms. This one will be can visit all rooms. Run it. In object is not iterable. Ooh, what the heck are you doing, man? What the heck? So it's not in for keys. No, it is room. Room index. And the keys has to be rooms, room index. And then, yeah, this one has. Okay. Submit. Pending. Accepted. Okay, so I want to see BFS one array solution. I forgot how to do one array. 2D array, 2D array, 2D array, or over an array. I don't know. Well, it gotta be. I forgot. Anyway, let's just straightforward BFS solution. Nothing else to be said, right? Think of the keys in each room as the link to the children. Link to the children. Yeah. We traverse this tree and keep a record of all the nodes that we have visited before. At the end, we check the length of the visited node and the length of rooms. If they do not match, that means some node, some room has not been visited. Alright, so the runtime will be on, because each node, each room will visit only once. Time is 68 milliseconds, which we run at 52% ranking. Okay? Very straightforward. I think this might be an easy question. I have a solution for this. Easy. It's considered medium. DFS, we don't do DFS. Easy question is harder than this one. We are staff now. Oh, yeah, that is staff. Please relabel it to easy. Yeah, should be an easy question. breadth first search. No, this is it's implemented as a implement as a depth first search, as a DFS, but with what? Huh? Why DFS? I'm not gonna implement DFS. Straightforward. Ha. DFS. They all do DFS. How? You have DFS, while DFS, pop, append. If this return true. Oh, we end immediately, and then going back. This very much like this, right? And this is just to take recursion into DFS, iterative version of DFS. I mean, and here it's basically the same, right? We append, and then we add, and then we pop out, we go to the next one. Yeah, it's just a regular traversal. This is a regular traversal. It's true, it's a regular traversal. But you have to write it this way because you cannot write it as a recursion because there's no, it's not nodes, right? You cannot, maybe you still can do recursion, but there's no need. You just push all the nodes onto the stack, and every time you pop from top from the stack, and go to the next one. All right, so this uses less memory compared to this, right? Because I have to add another one. So my question is, how do you do a BFS without BF? Yeah, you can do it this way. BFS, you have a queue, front dot insert. Oh, they use a data structure. They use the queue itself. Can I find oh man. Recursion, DFS. Oh man. Iterative with a list of visited rooms. Extend. Iterative with a stack. Oh, these are all the same with a stack. Pop if it is visited. Continue with pop if it's now we add it. Right? And then to visit we add. Oh yeah. Good solution. How do you do? I forgot. I must have simple DF is a one-liner. Jeez. Oh man. That is. No. I don't have the mental capacity for it right now. They all do DFS. Easier to code. So get a room, and not, and we add it, then we go to the neighbor. Yeah, that's true. But the thing is, I still don't know how to do this BFS with, please do not use, I think they still used up front. Shit. How do we do the BFS with only one queue, one array? What is like we know we don't need to, we can just use the index, right? We just use the index. But where are you going to put the new values? The new values has to go into a new queue, right? As we go through this, the new value, I cannot go into the same array. I don't even remember where I saw it. One of the challenges previously. Let's take a look. I am very intrigued. I want to see. All right, so I believe it's someday in the past. I'm looking through them. I shall have, every time when this happens, I shall have a big BFS, like it's right there. No, not this one. BFS, I have one that has BFS. DFS, BFS. What does it mean by BFS version of the DFS? Oh, I think, oh, this is for the level. Oh, it's not, oh, okay. Okay. Now I realize what is actually missing. Okay, so you have to use two arrays, but the trick, I think this is right. This is using two arrays, and then the things I was thinking about is you don't have to keep track on the levels. At this one, you don't have to keep track on the levels. Yeah. Now I got it. Now I got it. This is right. I think this is the optimal BFS. But we are going to write a DFS. So we're gonna stay true to our DFS, which is we're gonna use recursion to the DFS. I mean that's only true. We're gonna stay true to that. So we're gonna do def DFS, which is current room index, right? So we are looking at the current room index. What do? We're gonna go for key in rooms, room index, right? And say if key is not in visited, then visited.add key, and we need to DFS key. When we're done, now we're just done. Now we say DFS, we're going to do 0, and we're going to return, yes, I think this is, that's it. Syntax error is not in. Oh man, I was just trying to use all def. Oh my god, too much English into this. Yep. Yeah, this should be very straightforward. DFS with using recursion. This should be also fast. Yeah, this is an easy question. It's not medium at all. Submit. Yep, same runtime. ON, 68 milliseconds, 52% ranking. Okay, that shall be it. That shall be it for today. It's an easy one. We got a really easy one. It's just a another version of the regular traversal of a tree. So that's it. All right, that's it for today. We did a fast one, which is good, which is also in preparation for tomorrow. Right, tomorrow we expect it to be a little bit harder. All right, that's it. Adios.